join the math online classes or in-person classes that I'm taking for grade 3 to grade 10, and then also for SAT preparations. I would request you to send me a text message on my number 479-320-1982. Repeat, the number is 479-320-1982, and let me know if you are interested in joining your kid for the in-person classes on the weekends or for the online classes. And again, this is not an entertainment video where I would and hence I would encourage the kids and the parents to watch the video through to the end, so that you at least get a sense of how I'm teaching, and the kids who are kind of you watching this video to revise what is taught in the class. For them also, they have to watch the video to the end, so that way the purpose of the video uh, kind of gets fulfilled. Otherwise, if you're just watching it for a minute or two, it doesn't really help with anything, except for the new parents who are wanting to kind of get the number for making their kids join the class.
Yesterday we started with fraction and comparison of numbers, percentage, and all. But I felt that before I do that, I must make sure that all the concepts that you have learned till grade 4, that is at least no. At least I should feel comfortable that okay, you are very comfortable with all those concepts, and then I can increase the level for you. Okay, if I start teaching you 10th grade math, you'll start hating me soon. Okay. So let's do one thing. Today we'll do like a quiz. Okay, I will ask you different questions. I'll show you something on the screen also. Let me share my screen as well, and then we will see what are the things that you are comfortable with, and what are the things that we have to kind of learn one more time just to be more comfortable. Can you see my screen now?
Yes.
Can you see my whiteboard?
Yes.
Okay. All right. So let's start. I have a list of all the topics. So let's start with basic geometry. Okay. Do you know what is this? What is this?
Rectangle. A
What is
square.
this?
Triangle.
What is this?
Triangle.
Okay. This is called a right angle triangle.
Yes. Yeah.
Okay. And then, do you know what is this called if all the sides are same?
Uh. Nothing.
Equilateral triangle. Equilateral triangle. When all the sides are the same, it's called equilateral triangle.
Okay.
Yeah. Let's say a triangle when two sides are same. This is not. This is not same. This is called isosceles. This is called equilateral. Equilateral. Okay. Or AL. Equilateral. Equi stands for equal. Equilaterals. When all the sides are same. Okay. When the two sides are same, it's called isosceles triangle. Okay. All right. So this is this one. Okay. You know this?
Circle.
Yeah.
Rhombus.
Rhombus. When only two sides are parallel. Do you know what is that called? It's called trapezium or trapezoid. Okay. So the property of this shape is it's like a quadrilateral. Quadrilateral meaning something that has four sides. Okay. So this has one side, two side, three side, four sides. And only two of the sides are parallel to each other. Now you'll ask me, or I will ask you, what is a parallel side?
When it's like they never touch each other.
They never touch each other like the river tracks, right? The day railway tracks touch each other, the train will topple. Accident will happen. Something similar to that. So when you say uh, two lines are parallel, meaning they never touch each other, no matter how much you extend them. Okay, how far you travel, they will never touch each other. And also the distance between the two lines, the perpendicular distance between the two lines will be the same. So here, if it is 5 centimeter, here also it will be 5 centimeter. Here also it will be 5 centimeter. Even if you go two more miles further, it will be 5 centimeter. Okay, meaning parallel lines are a pair of lines when the perpendicular distance between the same remains the same and they never touch each other. Yeah. What is the difference between a square and a rhombus? You're on mute, Gitesh.
A rhombus doesn't have any parallel lines. A square has parallel lines.
May not be true. Okay. First of all, let's look at this. When you look at square or a rectangle, okay, two things that we must remember. Okay. One very important property of a square is that all its sides are the same length. Yeah. And every angle
Is 90 degrees.
90 degree. Okay. Same is the case with rectangle. Every angle is 90 degree. But all the sides are not the same. Only the opposite sides are same. This is equal to this. This is equal to this. Yeah. That's the only difference. So if you have to look at a rectangle or a square, rectangle is like the father. Okay, meaning it has four sides. All the sides are all the angles are 90 degree. Child is a type of rectangle where all the sides are also same. So opposite sides will be same for sure. Opposite sides are same and angles are 90 degree like the rectangle. But the only difference is if you call this as length and this you call as width, length and width in case of square is the same. Okay.
Yeah.
Now, when you look at rhombus, think of a situation where what you do is you are squeezing the square from the two corners, holding the two corners and you're squeezing it. Okay. And after you squeeze, what happens? Let me do this. This is your square. Okay. You took these two corners, okay, and started squeezing it because you don't like the shape of the square now. Okay. So square has all four sides same, all 4 degrees, 90 degrees, all angles 90 degrees. What happened is after you were squeezing it, it became like this. So whatever was the length of the side, that did not change. It just squeezed. It became thinner and longer. Okay. Meaning this angle became less than 90. Okay. This angle is less than 90. Sorry, the other way around. These two angles became less than 90 because you squeezed, right? This became thin at the top. And this became bigger than 90. Okay.
Yeah.
But if you look at the sides, it still might be parallel.
Yeah.
It is actually parallel.
Yeah.
You're just making it thin. So square was like this, you squeezed, it became thinner. Okay. But the sides are still parallel actually. They are not as symmetric as it was before, but they are still parallel. This side is still parallel. I will prove how it is parallel later in a mathematical way, not at this class, okay? Because I'll confuse you more. I don't
I
want to
see. I see how it's parallel.
Yeah, they are parallel. They look parallel. I will prove that mathematically also when we talk about level 2, okay? Don't rush. But one thing is for sure to remember, when you squeeze the square and make it a rhombus, it it still remains parallel. The side say, length of the side still remains the same. Only difference is the angles are not 90-degree anymore. Yeah,
Yeah.
the top angle and the bottom angle, this becomes smaller than 90, and these becomes the side from which you were kind of squeezing it, that becomes bigger than 90. Okay, you can try doing that. Okay, you can probably um, okay, if you have a toy at home which is little elastic in nature, you can try doing that and you will see the difference. Anyways, so that is on the uh, geometrical shapes. Okay, now tell me conceptually, and there are a few more to it, but we'll go to that later. Tell me, do you know the difference between area and surface area and volume? What is area, what is surface area, and what is the volume? Or let's say let's talk about area and volume first, then we'll go to surface area.
I only know area, but I don't know volume and
Okay.
surface area. That's the only thing I know.
Okay.
All those
So
three.
okay, fine. So this is the rectangle.
Yes.
This is, let's say, a square. Okay.
Mhm.
Okay. What is the area?
Um. Put. Can I can I draw on the screen?
No, no. So you just tell me conceptually. I'm fine. So you can just tell me. Okay.
Okay.
Area is nothing but the space that it takes
Yeah.
on the surface.
Yeah.
Yeah. Or a page. Let's say if you have a A4 sheet and you're trying to draw a rectangle or a square or a circle or a triangle. The area means how much of the space on the A4 sheet it will take. This is a bigger area. This is a smaller area.
Yeah.
This is a baby rectangle, which is taking lesser space on the A4 sheet.
Yeah.
This is this is daddy rectangle, taking more space. Yeah, and you can have a grandpa rectangle also, which takes more space. Yeah.
Yeah.
So area in simple terms is space taken on a page or on a surface by the shape, be it a rectangle, be it a square, grandpa square, daddy square, baby square. Yep. Daddy triangle, baby triangle. Yep. This is taking more space, this is taking less space. Yeah. So
Yeah.
this space taken by any shape on a sheet of piece of paper or on the any surface is called area. Clear?
Yeah. I know. Yeah.
Daddy circle, baby circle,
Yeah.
smaller brother circle, taking less space, little more space, even more space. This is area. Clear?
Yeah. Yeah. Yeah.
Now look at this. Look at my phone. Okay. What is this? Is this a rectangle? Is this a square? Is this a circle?
It's a rectangle.
It looks like rectangle, but it is not. Because rectangle is on a piece of paper. This has, see, if I call this as length and this as width, this has something else also called height. If my phone is very fat, then it has more height. If it is thin, it has less height. So it is a rectangle on one any side that I look at, but there's a rectangle here also. There's a rectangle here also. There's a rectangle here also. Right?
Yeah.
Like a dice. If you look at a dice, right?
It's
Dice
called the your phone is called a rectangular prism.
rectangular prism, or we call it a cuboid. Now, let me tell you. So, I was just giving an example. Okay. So, look at this guy. This is a, let's say, rectangle, or let's start with different thing. Let's put a square first. This is a square. Okay. You extend it. Does it look something similar to what we get from our fridge after freezing water? A
Mhm.
cube. Yeah, ice cube. It looks like an ice cube, right?
Yeah.
That's why it is given a name cube.
Yeah.
Okay. So cube is nothing but a three-dimensional shape, meaning three-dimensional meaning it has length, width, and also height. If you call this as length, this as width, this is height. Or if you call this as length, this as width, this is height. So this has three dimension, one, two, and third dimension. Okay. So far, whatever we saw, that was two-dimensional. Okay. So length and width, length and width. We looked at square. It also had this side and this side, right? Both were same. That is different. If you look at circle, it also was on the surface only. It did not have any height. Now we are talking about a solid shape where if you make a cube, meaning you make a square and extend, add height such that, okay, there's some background noise. Okay. There's another kid trying to join this class. Okay, no, that is for a different this thing. All right. So I will just give me a second. I have to inform my kid for something. Just one second. All right. Yeah, sorry for the disturbance. Okay, so what I was saying was, so we looked at cube, right? We make, you take a square which has length, all the sides same, right? And if you make it height so much so that this is same as this length, okay? So square has side, all the sides same, right? If you call it L, the height of the square also, if the height of the square is also same as the, this side, this is called a cube. Or in simple terms, a cube is a three-dimensional shape where the length, width, and height are the same. Clear? Gitesh, is that clear? Okay. So this is called cube. Now look at another shape. You had a rectangle. Imagine a matchbox. If you have seen a matchbox, okay, it is nothing but, or my phone. It's a little more fat phone. Okay, it has length, width, and height. But actually, it's like a rectangle is given some height. Okay, more height. That is how it becomes a shape like my phone or the matchbox that you would have seen. It is called cuboid. So the difference between a cube and a cuboid is cube has all the sides same, and cuboids can have different cuboids have all this, length, width, and height that could be different. Clear? So you can call a cuboid or you can call a rectangular prism depending on what you are comfortable with. You are on mute, Gitesh. I want to hear you if you have any confusion.
Can you repeat it again? I don't get it.
Okay, so you heard what is a cube, right? The ice cube.
Yeah.
The length, width, and height, everything is same. Okay,
Yeah.
that's why it is called a cube. If you look at a phone, my phone, or the matchbox, which looks like a rectangle from one side and it has some height.
Hmm.
So if you call this as length and this as width, this is the height. If the phone is fat or thicker, the height is more, right? So in case of cube, length, width, and height are all same. In case of cuboid, it is not. That's the only difference. Okay.
Um,
So if you look at a cube, if you take an ice cube from the fridge, which looks like a cube, and if you look that compare that with a matchbox, right? The big matchbox that we get in the Indian stores, you will see the difference. Here, everything, all the sides look the same. Here, the sides are different. Okay. Yeah.
yeah.
Okay. So this is the this part of it. Now let's look at some more concepts. Are you clear about the place value?
Yeah.
What is this one versus what is this one?
10,005.
So what is number five? What is the unit place value for five?
One.
What is the place value for this one?
Ones. 5 is ones and 1 is
Ten
10,000.
thousand. Yes. Okay. So this part you know. Let me. I'm just checking against all the concepts. Okay. Now, do you know how to add or subtract or multiply fractions?
Yeah.
How will you add this?
Um, I put the 1 by 3 on the bottom.
Okay.
No, okay. Just erase everything. Put 1 by 2. Yeah, it's there. And put 1 by 3 over. No, 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 not like that. Put
Uh-huh.
the 3 on the bottom. 1 by 3 on the bottom.
One by three like this.
Yeah.
I'm doing plus.
No.
I'm doing plus. I'm adding.
Yeah, you are. I know.
Okay. Do one thing. Can you share your screen? I want to see it. Or okay. Okay. Do one thing. Um, if you have to add fractions, I will do one thing. I will send you some sums. Okay. For adding multiplication, subtraction, and division of fractions, and you will solve that and send me back offline. Okay. I'll send the questions to your dad, and you can solve and send it to me. Okay. That's fine. All right.
Okay.
Okay. So I will give you questions on this one. I'm taking a note of that. Now, tell me, have you are you comfortable with the decimals? Let's say if I have
Yeah.
1.02 and I have 3.09, and if I have to add them, can you?
Yeah.
Okay. Uh, and these are practical things, right? I mean, this could be the price of toothpaste, it could be price of the toothpick, and you bought it from Walmart and you have to pay for it, right? So these are practical examples. $1.02. Okay. So this part, I'm just
4.11.
okay. 4.11. You did that also. Okay, very nice. Then okay. Now tell me, have you learned how to measure angles and all? Let's say you are given an angle like this.
Yeah. Yeah, that is
Do you know how to
a
measure it?
that's a cute triangle.
Like, that's a acute triangle. Okay.
It's
What
like a cute angle, not a triangle, an angle.
it's an angle? Yeah, you said acute angle. That's what I said. So acute angle is an angle which is less than 90 degree.
Yes.
What
Obtuse is more than 90 degrees.
obtuse is more than 90 degree. Okay, so that part also you know, and you know how to measure angle
No,
also.
no,
You don't know how to measure the angle?
no.
Okay. So measuring the angle is
They
something
have all the tools to
you have
measure
the
it.
tools. Yeah. That's how we do it. I mean, there's no other way to do it. We have the tools to measure the angle. Okay. So what you would have seen a tool like this. This looks like a semicircle, and you'll have point here. It'll have lines like this. Okay. It says this. Let's say this says 20 degree. This says 40 degree. So basically, you align this one with this one. So this center and this center, and this horizontal line with this one, and then wherever this line touches, that is your angle. That is
We
how you
have
do it.
this.
Okay. So this
This,
part,
are you saying this?
yeah, I was saying how to measure the angles. Yeah, yeah. All right. Okay, let's spend 10 more minutes, then we should be done. Okay.
Are you saying this?
Let me see your screen. Yes, correct. You're right. You
Or
know how
are you saying this?
this is for drawing the angles and all. Yeah, and you can also use it for measuring it. Yeah, yeah. But have you used them?
No, I don't know how to.
Okay, bring it in the next class. Next class, as in when you come for the test in the month of January, I'll show you how to use them. Okay.
Okay.
All right. Then we'll talk about. Do you know about this thing? Do you know what is this?
Uh, 10 degree, like 10 square, 10
Square 10
3
cube.
square, 10 3 square.
10 square, that is 10 into 10. 10
Yeah.
cube is 10 into 10 into 10, right? If you
Mm,
say 10 to the power 4, that means 10 into 10 into 10 into 10. Yeah.
okay.
So
Fine.
likewise, if you say x square, come on. If you say x square, it means x into x. If you say 2 square, that is 2 into 2. Okay. I'm just checking if you know these things or not.
Yeah, I do.
Okay.
I'm learning them right now in Vedic maths.
Right. So fine. So we'll start with power of 10. Powers. Okay. Now tell me, do you know what is volume? You said you don't,
Oh
right?
no. But you told me yesterday.
Okay. So we'll come to that. Okay. So let's do one thing. I'll stop it here. Okay. I will start with power and then I'll go to volume. That's what the plan would be. Okay. From the next class. So you enjoy your Christmas break. Take some time, unwind yourself, and we'll start with a fresh thing from grade 5. I see that you are comfortable with all the concepts till grade 4. So grade 5 maths is what I'll start. In next 2 months, I'll make sure that everything that you have to learn in grade 5 that is taken care, and then you will go to grade 6 and onwards. Okay.
Okay.
All right. So today's class is a short one. I think you are good to go. You can take some rest, finish up your remaining sleep, and then we'll talk again on 6th
I
of January.
am a super weird guy. Whenever I wake up, I never go to bed again until it's like 7 in the 8. I'm weird.
Yeah, no, I understand that. So take rest. That is anyways needed. And enjoy your vacation, holidays, and we'll talk again. All right.
Bye bye.
Bye bye. Take care. Say hello to everybody and happy Christmas from my side.